Anytime we're talking about consecutive integers, we're going to use x and x plus 1. Isn't that what a real consecutive integer would be? X and x plus 1. Consecutive means in a row, the next one. Okay, so if I have two consecutive integers whose product, and what does product mean? Multiply. Then what I'm really saying is x times x plus 1, which is the other integer, is equal to 72. This is the equation that we start with. Well, let's start changing this equation into one that we can use. All right, let's distribute first. That's x squared plus x equals 72, which now reminds us that this is a quadratic equation. If this is a quadratic equation, we need to set it equal to 0 to solve it. So now I have x squared plus x minus 72. Now this looks like something that maybe we can factor, and since this is about factoring, we already know. So I need to find something that multiplies to 72 but adds to 1. Why is it 1? Because 1 is the coefficient for the linear term. So 8 and 9 come to mind. 8 times 9 is 72. How do I make it work? Well, if it's a negative 8 times 9 is negative 72. Negative 8 times 9 is 1. So our factors are x minus 8 and x plus 9. Now, factors are not answers, so our answers, or our roots, are positive 8 and negative 9. Now, the hard part of this seems to be when we think about the answer 8 and 9, x is equal to 8. Therefore, x plus 1 is equal to 9. So our answers are 8 and 9. We are interested in consecutive, even whole numbers. So this time we are interested in x and x plus 2, because even numbers are separated by 2. So we are interested in two consecutive, which means in order, numbers. So that's x and x plus 2. The product is 224. So again, this is x times x plus 2 is equal to 224. So now I need to start working on something that I can use. If I distribute this, I have x squared plus 2x equals 224. And we now realize that this is a quadratic, and a quadratic has to set equal to 0. So x squared plus 2x minus 224. Now, since it told me this was practice in factoring, chances are I can factor it. So I need something that multiplies to 224 but adds to 2. Well, 14 and 16 will multiply to 224. And how do I make it work? Well, if I make the 14 negative, then they add to 2. So my factors are x minus 14 and x plus 16. Now, factors are not answers, so answers, or roots, are 14 and negative 16. This problem asks for positives, so what we have is x is 14 and x plus 2 is 16. So our answers are 14 and 16. Now we're finding two integers whose product is 105. But it doesn't say consecutive, so we need to look for a new relationship. There has to be some kind of relationship between the two numbers inside the Word document. It's not consecutive, so it's not x and x plus 1. So let's look right here where it says one of the integers is one more than twice the other integer. Right, so if one of the integers is x, the other integer is one more than twice it. So twice it plus 1. That's the other integer. So we have x, and the other integer is 2x plus 1. One more than twice the other one. So now we know that, again, this is a product, so that's x times 2x plus 1 is equal to 105. We need to get it in a format we can use. So let's distribute. So we have 2x squared plus x equals 105. We realize it's a quadratic, so we need to set it equal to 0. So this is 2x squared plus x minus 105 is equal to 0. Now, normally, 1, 2, 3, draw an x, and that's true. We're still going to do that. But instead of just taking 105, we have to think through this. What is different about this one? Well, it has a leading coefficient of 2. If it has a leading coefficient of 2, what we're looking for is what multiplies to negative 210. Now we mess around with our calculator a little bit, and we finally figure out that 15 and 14 multiply to negative 210. And to make it work, I need one of them to be negative, so we're going to make that one to be negative. Now right here, in our other problems where there's not a leading coefficient, we would say x plus 15, x minus 14. But this time we can't do that. We have to take a moment to go ahead and break it up into 4 pieces. So we have 2x squared, we have 15x, we have negative 14x, and we have negative 105. We took 1x and we broke it into 2 pieces. Now once we have 2 pieces, what's our best way to do 4 terms? 1, 2, 3, 4. If we have 4 terms, then I think the best thing for us to do is use a box. So again, here's what we have. We have 2x squared plus 15x minus 14x minus 105. And we're going to look for greatest common factors to help us break this down. So I'm going to put 2x squared here and negative 105. Does it matter which one of these we put in which box? It does not. But if you look at it, sometimes it's helpful to analyze which one would go better where. And if we put negative 14x right there, we see a greatest common factor. What is the greatest common factor of those two? Well, it's 2x, isn't it? If that's 2x, then this is x, and that's 7. That means 15x goes right here, so this is 15. And if we did it right, negative 7 times negative 7 times positive 15 is negative 105, which indeed it is. So our actual factors are x minus 7 and 2x plus 15. Now factors are not answers are they? We need to decide what our actual answers are, and one of those answers is 7, because 7 minus 7 gives you 0, which is what we're looking for. Now the other one is the weird one, so let's go ahead and do our mini equation, which is 2x plus 15 equals 0, 2x equals negative 15, x equals negative 15 over 2. Now our problem asked for positive integers. This is not a positive integer, so that means our answer is 7. Now let's go back to where we said x and 2x plus 1. So you're telling me that x is 7. Then what's the other integer? Well, 2 times 7 is 14 plus 1 is 15. So the answer to the problem is 7 and 15.